Okay, Bismillah. So we will start chapter 6, where in chapter 6 we have 3 types of structure that we have to deal with, which is trusses, frames, and machine. So we'll start with the easiest one first, which is the trusses. So in this class we'll go on the trusses, method of joints, and the reform method. So you should know what is or what is simple truss, and then how to calculate it. Now, what do we cover on this? Because in a real structure, you can see structure like this, or in 3D like this, right? Mainly they are composed by members that are quite small in diameter, right? Some might question why it doesn't need use like a steel plate or something. So there's a calculation and reasoning behind that. One of it is to save on the weight, but we have to know how to calculate and how to know that it is safe. Right? And then you might also see some structure like this. Why is it? It looks like it's just combination of like a thin member combined together, right? So is it why is most structure or many structure like that? So that's related to what we will be covering today, right? Same case here, right? Why is it not just solid metal, for example? Alright, so what is a truss? Truss is a structure composed by slender member joined together at their end point. So this is an example of the truss. So slender member, you understand what slender means? So this is one member, for example. So the whole structure is combination of this member that is joined at their end point. So this is end point, so it is joined for another slender member, for example, joined with another slender member, etc. You can build on. So basically, when you have combination of things like this is basically truss, right? Now, why is the category important? Because the way we analyze at the end will be different than different type of structure, right? So we'll cover on that. If it's 2D, then it is planar truss. So for example, this one is in one plane. Yeah. And normally in this chapter we only focus on 2D, right? Because for 3D, the caption will be much longer. All right. Okay, what next? So this is more to the concept of that relates the structure itself to the calculation method. There are assumptions that we apply which result in the analysis that we can use after this. So one is all loads are applied at the joint. The weight of the truss member are neglected because usually it's small compared to the load itself, right? So if you consider the member like this, every member have its own weight, right? But in this case, we ignore and we totally assume it is insignificant. So there's only just force here, for example, force there, right? And then another assumption is that every joint is combined with the smooth pins, meaning no friction. So based on these two assumptions, the result is we have two force members. Right. We have covered two force members before, right? How do you know if a member is two force member or not? From what we have covered? What is two force member? Huh? Same magnitude. Same direction. What do you mean same direction? Different direction. Okay. Now, we have covered two force member before, and it is needed to calculate in chapter 5, right? I think just one example that we have covered before. Something like this, right? Right. Before you even start, you have to identify is there any two force member, right? Is there any? Which one? This one? Okay, why? Why is this one two force member? Never. How do you determine that? Semi? Two pin, ada two pin. Kat mana yang two pin? Ni. Ya. Now what make this 2 force member? Okay, by definition, what is 2 force member? 15 member. 2 force member dia. Now, if we have this thing here, is this 2 force member? Kalau bentuk melengkung je ni. Ya juga, kenapa? If it's like this, is this 2 force member? Kenapa? Why? How do you determine is this 2 force member or not? Is this 2 force member or not? Is this 2 force member or not? 2 force, apa maksud 2 force? Apa? Siapa ada yang tahu ni? Baca apa tadi? Tak ngaku pula. Okay. Let's go on. Basically, it's a member where force acting on the member only act at 2 particular force, right? 2 particular point. So, for example, if you have forces like this is 2 force member because every force acting only at 2 point. This one will not be 2 force member because you have force here, and force here, right? This becomes 3 force member. You can have 2, 3, 4, 5, etc. Right? But 3 onwards, it doesn't matter because it doesn't change the way you can analyze. But when you have 2 force member, what's special on 2 force member? Because it becomes either tension or compression. Right? We have discussed. Please take a look at your notes. Why this is so? Because this is the only way it can satisfy summation of force equal to 0, summation of moment equal to 0. Right? Any different angle, any different combination will not satisfy this. So that's what's special for 2 force member. Now for thrust, every member is 2 force member. Why? Because if you notice that it is combined with another member, for example, another member, only at the end joint and end point, meaning that only 2 points for each member, right? Here it combined, etc. So every of this, now it will no longer become 2 force member if suddenly you have something like this. And then now you have 3 force member here, right? And if that happens, this is no longer a thrust. Because thrust is by dimension having only 2 force member in the structure, right? Because that is why we can analyze the way we want to analyze after this. If you have 3 force member, etc., you will have xy here. Because pin, originally pin has x direction and y direction, right? Now when you have 2 force member, then only you can omit the other one because it will be only in that direction. Okay. So method of joint. So there are 2 methods in the textbook that you can find how to solve for thrust. We will only cover one in our syllabus. I'm not sure why. I think it is to make it more simple for the student. But again, many of the things that we skip, for those who are from automotive aerospace, you have to eventually learn on your own because you have to use that anyway, right? Yeah. When I was a student, we actually covered the whole thing in the book. So I'm not sure why I noticed that here we skip many things, still we struggle to finish the syllabus. Okay. Now, the step. Okay. When we have method of joint, okay. Basically, the difference is like this. If you have structure like this, let's see. Right? If I make a different structure. Right. Method of joints, basically, it focuses on the joint. So you have one joint here, one joint here, one joint here, one joint here. And the free body diagram will be at the joint. Something like this. For example, point B, this is joint B, you have my free body diagram. The free body diagram will be basically like particle that you have learned in chapter 3, right? So the solve, so how to solve is exactly like that. Method of section, basically you just cut off, this become one section. So you actually cut off the member. So the way you analyze this one will be that totally different, right? The one that is easy is that one, right? But why for those who are from mechanical you have to know this one also, because some structure later on you have to know how to do this one anyway, because not all you can solve with this one when we deal with real complex structure later on. But anyway, so for statics first, okay, kita dulu baru kita fikir benda lain lah. Now we consider we focus on method of joint, right? So now I'm not sure why or how, because either some students actually have learned this before, meaning learn all before, or they didn't come to class and they cover on their own on the book. So in the exam, if you use the other method, because the answer scheme will only have this method, because we only teach this method, right? So it creates some issues last time, because why is the student use method that we didn't actually cover, right? Anyway, apa nak cerita ni? Okay, so the method of joint, basically you draw your free body diagram as such. We will go to the steps first, and then you apply summation of fx and summation of y. Now, the method indicate that we actually focus on the joint. So we'll cover this one first, the steps first, and then we'll go back to that example. So first, if the truss support reaction are not given, or we need to determine the support reaction, then you have to draw the free body diagram of the entire truss and then determine support reaction. And then draw free body diagram of the joint with one or two unknown. And then the rest is calculation, summation of fx, etc. Now, going back here, just to put things into perspective. Sometimes the question only wants what is the, okay, typically the question will ask what is the force of this and this member, and what the tension or compression, because as we understand, it can be only a tension or compression, the member, right? So you have to indicate, is it tension or compression, and what's the value. There are two possibilities. One is that you can straightaway solve by free body diagram of joint, and then you solve summation of fx, summation of fy equal to 0, right? But for some cases, you have to first solve support reaction. In this case, what? This is support reaction, this is support reaction, right? So in some case, we can skip that and still we can answer, because we are not concerned about that. We are only this form, right? If there's a way that we can straightaway solve, then we can save time there. But in some cases, you have to solve this one first, otherwise you cannot solve. Okay. In this case, okay, how do you determine that one? First is when you draw free body diagram of a joint, you only have two equations. So the maximum number of unknown is 2 unknown, right? So if you have any point where you only have 2 or less unknown, you can straightaway solve. If there's no joint with this unknown, meaning that you have to first solve for the support reaction. In this case, if we go joint by joint, right? How many unknown do we have here at the beginning? 2 unknown total. From what? From this one and this one. What about this one? What is this? This is local. So the reaction, support reaction will be normal, right? So how many unknown in total? In total at this joint, if you draw this joint here, let's see, right? How many in total? One from that member, one from that member, one is from local, right? So you have 3. How many here? So can you solve here? No, we don't have enough equation. How many unknown here? In total? One from here, one from here. How many from the pin here? 2, right? You have X and Y, right? And 4. How many unknown there at point B? 2, right? So in this case, obviously you can start at point B. Because you have 2 unknown, you can solve. Right? It will be different if at that point it will be another pin like that. So it's more than 2. So in this case, if this is the thing up there, then you have to solve the subordination first, and then if you have solved this one, then there's only 2 here, right? Or if you already solved this one, there's only 2 left, and then you can calculate. So that's the first thing that you have to determine, whether you need to solve this one first, or you can straight away solve the joint. So it depends on the question. Some question it will be given in the sense that you have no option but start here first. Okay, in this case you can start point B first. But if you want to do this one first, it will still give you the same answer. But you will waste some time in the perspective exam, because you don't need to go through all this. Because if you want to do this, you have to draw the free body diagram of the whole thing. And then you have X, Y here, from here. You have Y here, and then you have to solve f(x) for a moment, right? From that value you can use here to get the same answer. But the time wasted here might as well be used for other questions because it's not needed. Right? So that's the thing. Alright, so for this question, what do you do? Okay, you draw the free body diagram. Okay, here we can start at point B. So point B. Free body diagram meaning is the joint, the pin. What forces are there? So here we have 500 Newton. Now, this is, okay, to relate, this is the member, and this is member, we exploded, and then this is another joint, we have another member, joint. Now, if we consider this is in tension, it will be like this, right? How will you draw the corresponding force here for this member? Going up or down? If this is this. It should be the opposite, right?
Yes.
So that when combined, it will cancel, right? This one will be like that, right? If you assume this tension, it will be like this, so it will be like that, right? Let's say if you consider this as compression, meaning this is an example, right? Then what will happen here? Go like that, right? Now, so what I'm showing here is that to relate that if you consider tension, you will notice that it goes out from the joint. Tension, it goes out. Tension, it goes out. Compression, it goes in. Right? So simply going out, tension, going in, compression. Right? Because what happened to the member is actually compression, right? Because the member is actually tension. Right? Now, in the beginning, we do not know is it tension or compression. We have to assume, and then when you got negative value in the end, you know it's the opposite. If you assume tension, you get positive tension, you get negative compression. If you assume compression, positive compression, negative tension. Now, if you randomly assume, then in terms of examination, it can create confusion to the examiner. You understand? So it is advised that you have a standard way. For example, in the textbook they say just assume everything tension, so that whenever you get positive, you get tension, you get negative, you get compression, and it's easy to follow. Right? So in that case, if you take that advice, so if you draw point B, you have 500 here. For AB, if you assume tension, it will be going out, FAB. For BC, if you assume tension, you get FBC going out also. And then you have 12 degrees here, right? It will be like that. And then when you calculate, you get positive, then confirm tension, you get negative, compression. Of course, after this, you use summation of fx and y. Now, in the slides, or mainly in the slide, you will see something like this, where they already assume something tension, something compression. Why? Because they already know the answer. Now, there is a way that you can guess educated guess, right? For example, in this case, when this goes to the right, this for sure will go to the left to counter, because this is the only one have that. So you can have say, oh, I want to do that way. But why they do like this? So that everything will be positive. But if you do like this, okay, in this case, right, when you do summation of fx equal to 0, summation of fy equal to 0, you will get fbc some negative something. Then you say it is compaction, and then fab you get positive something, you say tension. If you do like this, fab positive, it is tension. fbc positive, it is compression, right? Now, I think for many students, I'm different with the student, this is easier to, because for this one you have to refer exactly back to your Fibonacci diagram, which direction you draw, right? This one is almost automatically, you don't need to refer positive, confirmation, so it's easier to follow when you want to check, right? So it's up to you, but one is what is easy for you, one is if you keep confusing the examiner. The worst case scenario, if you do not know how to, meaning for example, if you don't know how to guess but you still want to show as if you know anything. So you for example, you assume like this. And then this will be negative, this will be negative also. But this negative mean tension, this negative mean compression. So it will be too confusing for the examiner to follow, right? So make sure do not create headache to the examiners that might affect your grade. Okay. So that's generally how you solve. So basically what you do is you draw Fibonacci diagram at point B, you solve, meaning you solve this one already, right? These two. And then what do you do next to solve for this one? Because now you have three to solve, for example. Joint B, you can solve this and this. And then you have to go to the next joint to solve for the other one, right? Can I go to point A? Why? Now, okay, now after you have solved this one is known already. But you have three unknown, right? Here? When you have this one, you have only two, right? So you can solve. So that's how you progress from a joint to a joint to a joint to a joint. Right? Obviously in the exam it will not like this. I think if you see some previous exam, it will be like this. Something like that, right? So you start here for example, and then you go until the end. Yeah. So it will be quite long. No, it's not difficult, it's just long. Because you have to repeat the step again and again. And you will notice that the tendency for, if you make a mistake here, then the value will affect here, here, and here until the end. So you name it like so that's the thing. It's prone to error in that sense. Right? So make sure you always check the calculation. Alright, so what's next? Okay, that's the step of analysis. Now, zero force member. Okay, again, just to refresh, what is two force member? What's two force member? How do you know it's two force member? Force only at 2 point, right?
Yes.
Now, zero force member. Can you guess what it is? No point. No point. Yeah. Basically, it doesn't carry any load. Right. So here it is go into two ways of detecting just from visual if there is any two force member and how to detect the two force member, right? Now the first technique is, the first method is, if a joint, so you understand the joint by now, all of this is joint, only have two non-collinear member. You understand that? Meaning, if you have a joint, collinear meaning it makes one line basically. So if you have this two member, this is collinear. If you have this and this one, well, this is non-collinear. Right? So if a joint have two member, meaning there's another member, there's two member, and non-collinear, meaning like this, and no external force, meaning no force, no pin, no whatever, meaning no external. So both will be 0 force member. Meaning straight away you can say, if the question say find the force in each member, before you calculating, this is 0, this is 0, you can straight away say that one, based on inspection. So in this case, you can detect 2 points. One is here, where there's 2 member, non-collinear, no external force, 0 and 0. Similarly at point D, 2 member, non-collinear, no external force, 0 and 0. Is there any other? Now, if after this is 0, so meaning this is no longer effective, right? Meaning it's 0. At this point, you have 2 non-collinear, right? After this is 0, right? Is it 0 for number? Why not? You have external force. Right, so make sure you understand that. If there's no external force here, first you can see that 0, 0, and then here this is 0, 0 also, right? And then here is 0, 0 also, for example, right? So that can happen. Right, meaning that after calculating one, it affects the other joint after that, right? Okay, that's one inspection. Why is this important? Because it makes calculation easier, because now we can eliminate this two. Right. For example, right? For example, initially, can you solve here? Because we are finding which joint we want to start, right? For example, here initially you cannot, because you have 3 unknowns. But after you already know this one, then there's only 2, for example, right? So it can make some calculation easy. Now another inspection is, if you have at a particular joint, okay, it's a particular joint, you have 3 members, but 2 are collinear, meaning that you have 1 member like this, 1 member like this, and 1 member like this, for example. No external force, no other external force. So 2 collinear, and 1 the third one, so this will be 0. By the way, the example here that we show, for example, just now was this one, right? It can also easily be shown by equation, right? If you do summation of fs equal to 0, this will be 0, right? The summation of fy equal to 0, this will be 0. Right. Similarly here, right? If you do summation of fy equal to 0, this will be 0, because this is the only one with a y component, right? So it can easily shown. But this is also where this, when it's in this axis, then it's easily seen. But when you see like this, and it's joint, 3 non-collinear, 3 member, 2 collinear, the third one is 0, right? Similarly here, 2 collinear, the third one is 0. But if you have any external force, then it's no longer, you can no longer apply this. So these are the 2 inspections that they can do before you start your calculation. Any question? Is it understood? No. Ada point yang lain? Tak ada mana? Ini, ke mana? Okay. If we go back, because that's an interesting question. Now that's point A. If you look here, how can you say this is 0? Now, if you similarly here, right? When you say this is 0, right? What about this one? Kenapa dia 0? The point is, you already confirm it by looking here, right? So peduli lah benda tu. Tu kalau anak muda faham lah. E point E. Berapa gambar ni? Ini. Tak faham.
Tak kosong lah.
Yang mana yang tu? Ni, sini. Ni. F E B. Ni. Ini. Dengan ni. Kenapa?
kosong.
Kenapa kosong? Okay, tak. Okay, if you let's rewind. The first thing that you understand is what is the condition first? You have a join. How many? Two. So there's only two member. So if you have 1 and 2 non-collinear, then it's valid. If you have 3, 4, 5, you can apply this one. yang dua member je. Okay. So for example, this one, right? You have only 2 member. Similarly, right? For this one, you have 1, 2, 3, you cannot say anything. This one, you have 1, 2, 3, 4, you cannot say anything, etc. Okay. For your case, macam itulah. Meaning you conclude from this join. So, peduli lah point lain tu. Macam itulah. So similarly with the this one, right? You could make conclusion based on this join, not this join, right? Boleh ada kan? So it's just like when you calculate before, right? When you calculate, when you focus here to calculate this one, you bukan peduli apa yang kat sini. Itu kemudian lah. Macam tu lah. Okay, so is that understood? So those are the two. Okay, now with this, there are 2 or 3 possible scenarios. One is, meaning if you get any question, for example, in this case, it will make it easier because basically this will become 0, right? Now, in the exam, one case scenario is that if you have a problem where there is 0 for member and you can identify, it can make solving the question easier as it should be. That's one case scenario. Second, if there is 0 for member but you do not know, you didn't realize, your calculation will be longer because sometimes because of that you have to solve many things to get to the answer. So that's one thing. Meaning you still get the right answer but it will be longer. There's another scenario where, for example, this is not 0 but you say it's 0. Your calculation will be short but totally wrong. So sometimes I notice something like that happen in the exam. If from the starting point you make a mistake, say this is 0 when it's not, then the whole calculation will be affected and will be wrong. So make sure you understand why it is 0. Do not just 0 code. Then repeat code. Alright. How many 0 for member you can see here? Okay, there's a member here. How many in total? Someone say 1, someone say 2. Or 3 pun ada? Where, which one? Tu yang main tembak nombor je. Left? Top left? Meaning you also in this join, right? And this one, 2 member non-collinear, meaning this is 0, this is 0. Yang kata 1 tadi? Middle mana? This one? Kenapa? This one? 2 collinear, this one is 0, right? So the total is? Yang itu lah 1, 2 and 3, right? Campur lah, tambah. Okay, kira-kira tak tu member lah, dia tak main ni. Here can you say anything? Why not? Yeah, excellent. Right? Okay, hopefully you understand the concept. Let's try with the question. So, determine the force in all the class member and do not forget to mention whether there are intention or compression. So this is a standard type of question where you have to solve everything, right? So as I mentioned, if the way I draw the sample question from, so it will be much longer. Okay, how many answers do you have to provide in this question? How many members do you have? Kira 1, 2, 3, 4, 5, 6. Kenapa yang lama kan? Alright. Okay, in this case, do we need to solve? Okay, first question, is there any zero force member?
No.
Yes or no? Ada yang kata yes kan? If yes, kat mana? Kat C, kenapa kat C? At point C, can you say anything? Why not? This is an external force, right? So again, those two rules, you cannot have an external force there. If there's no external force, then this is zero, right? But in this case, you cannot say anything. If this is zero, if there's no force here, right? First, you can say this is zero, right? After that, you can say this is zero also, right? Remember, based on this point after that. But now there's no zero force member in this case. Okay, second, do you need to solve the support action first, or can you start anywhere? Is there any point where you only have two unknown? Where? Okay, you can say at point B you have two unknowns, so you can start here. Or at F, PD at point B. Okay, point D, you have 600 Newton. Okay, if we take an assumption that everything is tension, so you have F, DE, F, CD. What's the angle here? What's the angle? If you use a triangle, what is a triangle? The big triangle here? 6, 8, 10, right? Or 3, 4, 5. Remember? 6, 8, 10, right? So you can use it. Or you can use 3, 4, 5. It's the same triangle. Alright. How to solve? Summation of fx equal to 0. If you take positive to the right, you get minus 600 minus FDE 6 over 10 equal to 0. So FDE will be minus 600 10 over 6, which is minus 1000 Newton. Meaning what? Tension or compression? Compression. Why? Because we take everything tension, everything, so positive tension, negative compression. Meaning it's actually in that direction. That's the meaning of this negative. And then summation of Fy equal to 0, taking upwards positive. Now, if we are still using this figure diagram, summation of y will get minus FDE, right? But FDE, the value is negative 1000. And then you have 8 over 10. And then minus FCD. Right, minus plus. FCD will be 800. Newton, compression or tension? Tension. So you have to solve for it. Right. So there's two ways to understand this. Not to understand, to do it. Because when you get negative, actually it means that direction. Either you redraw and then you get in there, or you just use this one, so it's minus because it's downward, but the value, this is the exact value there. Based on this diagram, right? So you have to plug in negative here. Okay, then which point next can we go? Can we go to point E? Why not? Now we have solved this and this. You go here, how many unknown? 1, 2, 3. You can. How many unknown? 1, 2. You can, right? So free body diagram at point C. So you get 900 Newton. Alright, FCD. You have already it's 800 tension. How do you draw here? Good. 800 Newton. Why? It's tension going out, right? So if you assume tension for everything, you have something like this. So FCE, FD, Summation of fx equal to 0, you get minus FCE minus 900 equal to 0, FCE equal to minus 900 Newton, meaning compression. Summation of Fy equal to 0, of course it's positive, so you get 800 minus FBC equal to 0, FBC equal to 800 Newton tension. Right? Next, free body diagram at point E. So, okay. FDE, what you have is 1000 compression. How do you draw it? So you're going in like this. 1000. Right? So we already take the compression direction. So value should be just the value. Do not put. If you go negative, then it's counter. So it's not right. FCE, mana FCE? FCE is compression also. So going in also 900 with that. So you assume tension for these two. So this is FAE, FDE. The angle is the same, right? So it's basically 6, 8, 10, 6, 8, 10, 6, 8, 10. Okay, this will result in simultaneous equation, right? With the summation of fx equal to 0, you have all that minus 1000, 6 over 10, minus 900, minus FAE 6 over 10, plus FBE 6 over 10 equal to 0. Summation of Fy equal to 0, you have minus 1000, 8 over 10, minus FAE 8 over 10, minus FBE 8 over 10, 0. Simultaneous equation, you can solve for both. Okay, so again, as we mentioned, it is just a repetition of the same step. Free body diagram, fx of y, free body diagram, fx of y, free body diagram, fx of y, until the end. Of course, the implication is any problem here will make the whole thing contain an error, right? So make sure you understand that and check for anything. Any question? You understand how we solve for trusses? Now, if you look at the slide, there's a preliminary like this. So FDE is assume compression, FCD is assume tension, right? Why? Because they already know that's the direction. So it will tell you that FCD will be tension, FDE will be compression. Right? So the difference is that if you have the slide like this, FCD will be positive, FDE will also be positive. But this positive is compression, this positive is tension because it corresponds to this one. Make sure you understand if you refer to the slide and why is it different than what I show. Because I show, just to be consistent, everything we always assume tension. That one they just straight away put in the direction of the answer because they already can guess what the answer is. Similarly here, but this one is quite obvious, right? This one, right? So again, as I put here tension and tension, so this will be negative and positive. In this case, they put in this way, so both will be positive, but one is compression, one is tension. But this one, I think is most students will never be able to guess which is compression tension because it's simultaneous. It's not that. So the slide already do know the answer anyway. So as you can see, positive, one compression, one. So I'm just showing as long as you understand what's going on in the slide and what's going on in what we teach, and as long as you understand and you can apply correctly. Any question? Okay. Okay, this is just to see whether you are paying attention quiz. So if this is free body diagram and you solve FPC, you get minus 500. So is it tension, compression, or cannot be determined? Compression. Now that's the end of the slide for thrust. Right. After this, we'll go to frame and then we'll go to machine. Which if you notice, this one will the way we answer is more towards the particle equilibrium. Frame and machine is more on chapter 5 because we have different type of support and then etc. So you have moment, etc. So the number of equation is more, and yeah, it's most student will they are afraid on that part because even the diagram is more scary than this one. All right, now so we have still time. Now in the slide, if you notice, they always they didn't show any example where you actually need to solve support action first. Right, this is an example. Because that's where I think if you think every question is like in the slide, then suddenly you see in the exam, it might be your assumption will be wrong. Right? I take a contour. This one you can solve. This is an example. This one. Okay, here, right? If I show this one, can you see? Okay, you just look at the example. The diagram. Can you solve straight away, or you have to solve support action first? There's no point that you can solve straight away. At point B, you have how many unknown? 3, right? So basically, this is an example where you have. Okay, how do you solve support action first? What do you need to do? Just go to chapter. Chapter what is determine support action? Chapter 5, right? So you have to draw the whole thing. And then you have force, and then here you have what do you have? At A, X and Y, what number? This one? Y is that? Right? And then you do summation of Fx, summation of Fy, summation of moment. You have solved this one, and then and this one is given. Then only you can consider the join. Right. So this is an example where you have no other option other than solve this one first. So this is where you have to, if you understand this one in this kind of question, but you cannot do this one first, then or you make a mistake here first, which is chapter 5, you make a mistake, then you will affect also the calculation. Right. So that's how it's connected. This is an example. And also it is advised that you do try a question like this because the angle is more, because this one is too simple, right? Meaning this angle is more challenging, I think, if you do the that one. We have sine, cosine, etc. For this one, can you solve straight away or you have to determine support action first? Nampak? This diagram. Right, because here you have 3 unknown, here you have 3 unknown, so you have to solve this one and this one first, right? So there are a lot of examples. This is example from your textbook, example 6.3. That where the problem you have to solve support action first. So do try those kind of question also. Because it's just combination of chapter 5 and chapter 6 to see if you have any problem, right? This one? Okay, first question. Is there any 0 force member? Where? Which one? Where? Which one? First. Point? G. So this one meaning what you can conclude? This one is 0. Okay, then? D. This one is 0. Then? Is that all? After this is 0, if you look here, you have only 1, 2, 3 collinear. This one is also 0, right? This one you cannot see anything because external, right? This one 1, 2, 3, 4 cannot. So you have 3 Zero for angle, right? And then what? But still after that, can you solve? Do you need to do support relation first or not? In this case, at this point, you have still with this 0 and 0, you still have 1, 2, 3, right? 1, 2, 3. So you still have to solve AX, AY, and this normal, right? So these are examples that you should try and see if you have any problem to solve. Right? Similarly here, many examples you actually do not have. Okay, do try also question like this. Because there's a different. But I guess some students I think are struggling with trigonometry. So make sure you have exercise with trigonometry. Meaning even you understand this concept, but you struggle with sine, cosine or whatever, then it's still a problem in the exam. Right. Now, okay, in this case, how many zero for remember? You do again. BH, this one is 0. Here, right? And then this one you cannot see because this is external, right? If this is 0, is this 0? Why not? This is not collinear, eh? You cannot just simply no, this tak sahaluan. There's only okay, okay, that's the only 0, right? Okay, so there are a lot of examples. These are all examples from your textbook. So I'm just showing just to show that even though our question we can straightaway go to the point, not all questions are like that. And you can see there's a lot of questions. You actually first have to draw the whole thing, solve the pin, support, roller, etc. before you can apply this thing. Alright, so with that, I think. Okay, for this type of question, what you need to do is just perform sujud syukur dekat masuk exam. This is 3D. There are also calculations here, but it is not included in our syllabus. So it's already making your life much easier than you have this kind of question, right? Anyway, so in the next class on Thursday, in the next class you will have 2 quiz on chapter 10. Just now we have chapter 9, right? So you have 2 quizzes in chapter 10. One is integration, one is composite, where you have combination of shapes that we have covered before, right? So just be prepared for both. I want to finish off chapter 10 so that next week your quiz is already in chapter 6. Right? We have 2 chapters to cover, chapter 6 and chapter 8. Chapter 6 is quite big because we have different types of structure. Alright, so next class we have a quiz, and after we finish the class I'll pass on to. I only managed to mark one of the 4 already. Just to see, because I think this is integration, so just to, for some of you, because some of you struggle with integration or something, just for you to see where you get it wrong and for you to prepare properly for your integration for this quiz. So with that we end the session. Inshallah, subhanakallah wa bihamdih. Right. So this is for the brothers, this is for the sisters. So with that we end the session.